you've eaten them 1,000 times. You know the red carton, you know the satisfying crunch, and you definitely know that perfectly salted, fluffy interior. It's the undisputed icon of fast food, a global comfort food you can find in almost every corner of the world. Every single day, humanity eats millions of pounds of them. But what if I told you the simple, humble French fry is one of the most complex, high-tech, and precisely engineered foods on the planet? What if its journey is more epic, more scientific, and frankly, more fascinating than you could ever imagine? After you see its incredible secret journey, you will never look at a French fry the same way again. This isn't just a story about cooking. This is the untold story of how a humble potato is chosen, harvested, scanned, blasted, and frozen to become a global fast food icon. We're going deep inside a world of staggering scale, where millions of potatoes an hour are transformed by incredible forces of nature and mind-blowing feats of engineering. This is its secret life, from deep within the earth to the moment it reaches your plate. Chapter 1. The Chosen One, a potato born for greatness. Our story doesn't begin in a sizzling fryer or a bustling factory. It starts in the quiet, dark earth of sprawling, specialized farms. Because let's be honest, not just any potato has what it takes to become the perfect French fry. The ideal candidate is a specific variety, usually a russet Burbank, a long, oval-shaped potato famous for its unique qualities. These potatoes are high in solids or starch and low in sugar. This balance isn't an accident. It's the secret to the fry's signature texture. It makes the inside fluffy and light, with a structure that holds up during frying to become perfectly crispy. Too much sugar, and the fry would brown too fast, burning before the inside is cooked. Too little starch, and you'd get a limp, oily mess. Cultivating these elite potatoes is a year-round science. These farmers aren't just growers, they're data analysts and environmental stewards. They practice regenerative agriculture, a method designed to work with nature, not against it. This means disturbing the soil as little as possible, planting cover crops to protect the earth and lock in carbon, and rotating their potato crops with plants like legumes that naturally replenish the soil with nitrogen. This isn't just good for the planet, it creates healthier soil, which produces a higher quality potato. Water management is another huge factor. Potatoes are surprisingly water efficient compared to other major crops like rice or wheat. Modern farms take this a step further, using precision irrigation that can cut water use by up to 30%. Sensors in the fields give real-time data on soil moisture, letting farmers deliver the exact amount of water needed, right where it's needed. For several months, agronomists work side by side with farmers, monitoring the plants from the first sprout to the full canopy of leaves. They use integrated pest management, which prioritizes natural predators, like beneficial insects, over the widespread use of pesticides, protecting the whole ecosystem. Finally, after months of careful work, the moment of truth arrives. But before the harvest begins, a strange and crucial step takes place. The plant leaves are deliberately shredded and removed. This act, called defoliation, stops photosynthesis, signaling to the potatoes underground that it's time to mature, firm up their skins, and get ready for the journey ahead. They are now ready. They've been bred, nurtured, and scientifically perfected for a single destiny: to become the perfect French fry. Chapter 2. The Great Harvest, a Race Against Time. The harvest kicks off in the cool air of late summer and early autumn. What was a quiet field becomes a scene of immense mechanical power. Specialized potato harvesters, true behemoths of modern farming, move across the rows with relentless precision. These machines aren't just crude diggers, they are remarkably gentle giants. They carefully lift the earth and the precious potatoes onto a series of conveyor belts. The main challenge here is separating potatoes from soil, rocks, and vines without causing any damage. A bruised bruise isn't just a cosmetic flaw. It's a defect that can create a dark spot on the final fry. The harvesters are designed to minimize this risk, using vibrating belts and soft rollers to gently shake the dirt loose while cushioning the potatoes. These machines can process acre after acre in just a few hours, a symphony of efficiency ensuring the potatoes are lifted from the ground in peak condition. Once unearthed, it's a race against time. From this moment on, quality is a ticking clock. The potatoes are collected in massive bins and moved to climate-controlled warehouses. These aren't simple sheds. They are sophisticated facilities where science holds spoilage at bay. The temperature and humidity are precisely regulated to keep the potatoes from sprouting or rotting. Storing them in this state of suspended animation is critical for a year-round supply to the mega factories that never sleep. Potatoes destined for processing are kept between 6 and 8 degrees Celsius, the sweet spot for managing their sugar content. This is also where our potato gets its birth certificate. Traceability is paramount. Batches are meticulously logged, linking them back to the specific field, harvest date, and farmer. This invisible chain of data will follow them on their entire journey, a crucial tool for safety and accountability. If a problem is ever found, producers can trace it to its exact origin in seconds. After a rest period in these carefully managed environments, the potatoes are called to their next stage. The slumber is over. The transformation is about to begin. Chapter 3. The first leg of the journey, the road to transformation. The journey from the farm-side warehouse to the processing plant is the supply chain's first real test. The potatoes are loaded into massive, temperature-regulated trucks, each one a mobile extension of the controlled environment they just left. Every mile matters. Logistics coordinators orchestrate a non-stop flow of these trucks, ensuring a steady, unbroken supply to the factory doors. A single mega factory can process millions of pounds of potatoes a day, so any interruption would bring the entire operation to a grinding halt. It's a marvel of just-in-time delivery on an almost unimaginable scale. Upon arrival, the trucks pull into enormous receiving bays. Here, the potatoes face their first quality control inspection. Samples are taken from each truckload and rigorously tested for size, solidity, sugar levels, and any sign of damage. Advanced optical sorting machines use cameras and sensors to scan the potatoes, identifying imperfections invisible to the human eye. Any batch that doesn't meet the incredibly strict standards is rejected. But rejected doesn't mean wasted. In a system built for sustainability, these potatoes are often diverted for other uses, like animal feed. Over 99% of every potato that enters the system is either used or reused, ensuring waste is kept to an absolute minimum. Once a truckload is approved, its contents are gently unloaded onto a river of conveyor belts, disappearing into the cavernous mouth of the factory. The roar of machinery is deafening. The scale is breathtaking. They have passed their entrance exam. Now their trial by fire, water, and steel begins. Chapter 4. The Gates of Transformation. Arrival at the mega factory. Inside the factory, the potatoes enter a world of pure automation. First, they have to get clean. They're sent through a dirt eliminator and a destoner, powerful machines that use water and vibration to separate any remaining soil or pebbles that hitched a ride from the farm. Next, they flow into massive washing systems, where they are tumbled and scrubbed by powerful water jets and soft, rotating nylon brush rollers. This process is meticulous, ensuring every potato is perfectly clean before its skin comes off. The water itself is part of a sophisticated recycling system that filters and reuses it to cut down on waste. Now comes the peeling, and it's nothing like a hand peeler. The most common method is steam peeling. The potatoes are fed into a large, rotating pressure vessel and blasted with high-pressure steam for just a few seconds. This causes the water just under the skin to flash into steam. When the pressure is suddenly released, the steam expands, popping the skin right off. The potatoes then tumble through soft rollers that gently rub away the loosened peel, preserving as much of the potato as possible. The removed skins are collected and repurposed, usually as a component in animal feed, another link in the sustainability chain. Even after this, perfection is the goal. The now naked potatoes glide along a manual sorting platform, where trained workers give them one last look, trimming away any eyes or green spots the machines might have missed. These peeling lines can process thousands of pounds of potatoes every hour, a relentless flow that feeds the insatiable appetite of the factory. The potatoes that entered as rugged, earth-covered individuals are now smooth, pale, and uniform, ready for the step that will give them their iconic shape. Chapter 5. The cut, where engineering creates an icon. This is the moment the potato becomes a fry, and it happens in the blink of an eye, thanks to one of the most astonishing technologies in the factory, the hydro cutter. Forget knives, these factories use the sheer power of water. The peeled potatoes are fed into a system that uses water to orient them lengthwise. Then they are launched at speeds up to 70 miles per hour through a grid of razor-sharp blades. The water acts as a high-speed piston, shooting the potato through the cutting grid in a fraction of a second. This method is incredibly precise, ensuring every single fry is cut with uniform dimensions, usually around 3/8 of an inch. This consistency isn't for looks, it's critical for making sure all the fries cook evenly later on. Some of the most advanced factories use another mind-bending innovation right before the cut: pulsed electric field, or PEF technology. For a microsecond, the potatoes get a gentle electric shock. This doesn't cook them but perforates their cellular structure, making the flesh softer and more pliable. A PEF-treated potato is way easier to cut, resulting in a smoother surface, less breakage, and even more uniformity. It also means the blades stay sharp longer. The cutting grids themselves are interchangeable. By simply swapping one grid for another, the factory can instantly switch from producing classic straight-cut fries to crinkle cuts or wedges. It's a system built for precision, speed, and versatility. As the newborn fries emerge, they're not all perfect. The cutting process creates small slivers and imperfect pieces. To get rid of them, the fries pass over a vibratory grader, a machine with precisely spaced rollers that let the smaller nubbins fall through, while the perfectly long fries continue on. Only the best of the best move forward. The journey of our fry has taken a pivotal turn. It now has its iconic shape, but its most important trials are still ahead. Chapter 6. The trial by water, blanching and drying. The freshly cut potato strips now head to one of the most chemically important stages: blanching. They are immersed in massive tanks of hot water, typically heated between 70 and 95 degrees Celsius for several minutes. This hot water bath might seem simple, but it's a scientific process with multiple crucial goals. First, blanching stops the enzymes that would otherwise cause the fries to turn an unappetizing brown or gray color and develop off flavors. It locks in that desirable pale, creamy look. Second, and maybe most importantly, blanching washes away excess sugars from the surface of the strips. Even though the perfect fry potato is low in sugar, some natural sugars are always there. If left on the surface, these sugars would caramelize too quickly in the fryer's hot oil, resulting in fries that are dark or even burnt on the outside before the inside is cooked. By removing these sugars, blanching gives the restaurant chefs precise control over the browning process, ensuring that signature golden color every time. Finally, this process starts to gelatinize the starch on the fry's surface, the first step toward creating a crispy outer shell and a soft, fluffy interior. After their hot bath, the fries immediately move to the next critical phase: Drying. They're spread onto long conveyor belts that pass through enormous dryers. Here, controlled airflow removes surface moisture. Frying a wet potato strip would cause the hot oil to splatter dangerously and would result in a soggy, oil-logged product. The goal is a perfectly uniform moisture content, ensuring the fry will become crisp, not greasy. Our fry has survived its trial by water. Now, it must face the fire. Chapter 7. A taste of fire, par frying, and the deep freeze. The dried fries are ready for their first encounter with hot oil. This isn't the final frying. It's a crucial step known as par frying, or partial frying. The fries glide into massive industrial fryers, vast pools of vegetable oil heated to a precise temperature, often around 180 degrees Celsius. They're cooked for only about a minute. This brief, intense bath does several key things. It creates a thin, protective outer layer that helps the fries hold their shape. It also begins the cooking process and imparts the first layer of that delicious, fried flavor. This step is what guarantees the fries will have a crispy exterior while the inside remains soft and steamy like a baked potato. The oil itself is a marvel of technological control. It's constantly circulating through a filtration system that cleans every drop every 30 to 45 seconds, removing any microscopic food particles to keep the oil pure and the flavor consistent. Immediately after emerging from the par fryer, the golden fries move on to a de-oiling conveyor, a vibrating belt that gently shakes off excess surface oil. This is vital for reducing the final fat content and preventing a greasy texture. Now, our fry is about to undergo its most dramatic transformation yet. From the heat of the fryer, it's conveyed directly into a flash-freezing tunnel. Here, it's hit with blasts of frigid air, far below freezing. Within minutes, the fry is frozen solid. This rapid freezing is essential. It locks in the flavor, texture, and freshness. By freezing so quickly, it prevents the formation of large ice crystals that would damage the potato's cell structure and lead to a mushy texture when cooked. The flash freeze ensures the fry that goes into the bag is in a state of perfect suspended animation, ready to be awakened in a restaurant fryer months later, tasting as fresh as the moment it left the factory. Chapter 8. The Age of AI, the all-seeing eye of quality. Throughout this high-speed journey, quality control has been constant. But in the most modern mega-factories, this process is now powered by artificial intelligence. While human inspectors are still vital, they're augmented by AI-powered systems that see and analyze with superhuman speed. As the fries, freshly cut, blanched, or par-fried, race along the conveyor belts, they pass under high-speed cameras and sensors. These are the eyes of a virtual quality assistant. This AI computer vision system scans every single fry in real time, measuring its length, width, and thickness down to the millimeter. It detects any discoloration or imperfection that would ruin the final product. If a defective fry is identified, a piece that's too short, a strip with a green edge, the AI instantly triggers a targeted puff of compressed air. The puff knocks the single offending fry off the conveyor belt into a rejection bin, all without ever slowing down the line. This happens thousands of times an hour, an invisible guardian ensuring only the highest quality fries continue on. But the AI's job doesn't stop there. It's constantly collecting and analyzing data, looking for patterns a human might miss. If it starts detecting a higher percentage of short fries, it can alert operators to a potential issue with a cutting machine. If it sees subtle color changes after blanching, it can signal that the water temperature needs adjusting. This is innovation in the service of both efficiency and quality, ensuring the promise of a perfect fry is kept billions of times over. Chapter 9. The Final Steps. A Journey in Hibernation. After the flash freeze, our fry is on the final leg of its factory journey. It travels into the packaging hall, a symphony of automated precision. Here, sophisticated machines called multi-head weighers do the work of a dozen hands in a fraction of a second. The frozen fries are dropped onto a central cone, where they vibrate down into a series of small buckets. A computer instantly calculates which combination of buckets adds up to the exact target weight for a bag. Those buckets open, dropping a perfect portion down a funnel. Below, branded bags are formed, filled and sealed in one seamless motion. Some systems even flush the bag with nitrogen gas before sealing, pushing out oxygen to protect the fries from freezer burn and preserve their freshness. Every bag is checked for weight and seal integrity. Robotic arms then pick up the filled bags and place them neatly into cardboard boxes. The boxes are taped shut, labeled and stacked onto pallets by another set of robots. The entire process, from loose fry to palletized product, is a dance of automation. These pallets are then moved by automated guided vehicles to vast cold storage warehouses, enormous freezers kept at a constant, frigid temperature, typically below 18 degrees Celsius. This is the final holding area, a silent, frozen world where millions of fries wait for their shipping orders. But the factory's work is never truly done. The relentless 24/7 production takes a massive toll on the machinery. That's why these mega factories follow a strict and uncompromising maintenance schedule. After running continuously for weeks, the entire production line is shut down for a marathon cleaning session that can last for 24 to 48 hours. A dedicated crew descends on the factory floor, cleaning every machine from the inside out. Every conveyor is scrubbed, every pipe flushed, every surface sanitized. This isn't just about cleanliness, it's a fundamental pillar of food safety. This rigorous cycle is the unseen commitment that ensures the safety of every single fry. Chapter 10. The last mile, from your order to your plate. The fry's journey is almost complete. From the cold storage warehouse, boxes of frozen fries are loaded onto refrigerated trucks, their cold chain meticulously maintained as they travel to distribution centers and, finally, to thousands of restaurants around the globe. They arrive still frozen solid, a testament to the integrity of the supply chain. At the restaurant, they're stored in freezers, waiting for you. When you say, "I'll have a large fries with that," the final, fiery act begins. A basket of frozen fries is plunged into a commercial fryer, preheated to a precise temperature, usually between 175 degrees and 190 degrees, 350 degrees and 325 degrees. They cook for about 3 to 4 minutes. This final fry is what transforms the par-cooked, frozen stick into the masterpiece of texture you expect. The intense heat quickly cooks the fluffy interior while making the preset outer layer achieve its final, glorious, golden brown crispiness. The fryers are equipped with automated timers and basket lifts, ensuring every batch is cooked for the exact same amount of time, delivering unwavering consistency. As soon as they're lifted from the shimmering oil, they get a gentle shake and a light dusting of salt. The transformation is complete. The potato that began its life months ago in a carefully tended field hundreds or even thousands of miles away is now placed in that iconic carton and served to you, hot, crispy, and perfect. From a single, specialized seed, our potato has been on an incredible odyssey. It was cultivated with sustainable practices, harvested by gentle giants, and given a digital passport for a journey of total accountability. It was washed, scrubbed, and steam blasted inside a factory of monumental scale. It was given its shape by a blade of pure water, softened by an electric pulse, and refined in a hot bath. It was partially fried in perfectly clean oil, flash frozen in an Arctic blast, and scrutinized by the all-seeing eye of AI. It was weighed and bagged by robots before traveling the globe in a state of suspended animation. Finally, it was awakened by a final blast of heat, ready to be enjoyed in minutes. The French fry is so much more than a side dish. It's a marvel of modern agriculture, a triumph of engineering, and a testament to a global logistics system of mind-boggling complexity. It represents the meeting point of science, technology, and a dedication to quality that follows a single potato from the soil to the salt. So the next time you pick up that perfectly golden, crispy fry, take a moment. You now know its secret life. You know the incredible, unseen journey it took to get all the way to your plate. If you want to uncover the secrets behind more of your favorite foods, be sure to subscribe for more stories of how it's made. You'll never look at your plate the same way again.